And what we realized was by observing the light reflections of celestial bodies, you can make assumptions about their what they're made of. So
now what is the current situation like?
We already kind of managed to go to an asteroid, take something and turn it back. I think India actually last year or even beginning of the year sent their first lander, if I remember correctly. And I mean, there is a lot on an asteroid that what we can bring back will make economic sense.
And in future also, like once we get to a point where you can kind of like afford those things, the developed countries will just enter into a race to
know that I think there is one coming in 2026, for example. And that's something people don't usually know about asteroids, is that asteroids are not like solid stone. The very compact piece of material inside of your probe.
So tell me about what is asteroid mining actually?
Okay, so asteroid mining is literally what it says in the name. We want to go into space to mine asteroids. And yeah, the reason we're doing that is basically that we figured out that asteroids have a lot of rare earth minerals, which we can utilize on Earth. And it's actually a lot of them. It's not just a little bit. And mining those represent a very big business opportunity.
About the thing, like how did that actually started? Like who were the kind of the people who started this thing out?
So I think the first time I read a paper, like the first time that was mentioned in like papers in scientific research was around actually already in like the 90s in the last century. So 1990s, 1995, I think is one of the papers. And what we realized was by observing the light reflections of celestial bodies, you can make assumptions about their what they're made of. So we know, for example, that Saturn has certain properties and has certain materials based on the light that it reflects long before we even send any spacecraft there. The first people who in theory even thought about, okay, this is like a thing that makes even sense to do, that was around the 1990s, or at least that's the first time I heard about it. Basically at the time you didn't have, in the 1990s, the rocket industry was kind of on sleep mode, I would say. We did have the space shuttle, but we didn't have the infrastructure that we have today with SpaceX and with Blue Origin and all of the other players. So it was very governmentally focused. And the other thing that happened then in the 2010s, we had deep space mining and planetary exploration industries, I think, were they named. And those were kind of the first people who actually opened a company. I think James Cameron, the director of Avatar, for example, he dumped a shitload of money into that. And then right now we are kind of the second batch. So my company, Asteroid Mining Corporation, and there are a few others who are also moving in the general direction.
This is a very interesting story of starting out, because I also researched a bit about this thing, and there was no clue that was saying that these people started this, or just I had a question about that. And on internet also it is barely mentioned how that was started and who started this. So that was an interesting question. Also coming back to this thing, asteroid mining, now what is the current situation according to your prediction, where when can we completely start off this thing and totally depend on asteroids for mining?
In terms, maybe I go a bit into what we've done so far as a community of people who are doing this. We had, I think by now it's 3 missions. We had the OSIRIS-REx, which I think concluded last year from the Americans. And then we had from Japan, Hayabusa 2 and Hayabusa 1 missions, where the first missions that retrieved samples from asteroids. And when I mean sample, I mean literally grams. We're not talking about even a kilogram yet. So we already kind of managed to go to an asteroid, take something and turn it back, but not in a capacity that would make economic sense as of now. So what is happening now is that you have different players looking at different parts of the problem in a sense. So we're building our robot to do prospecting on an asteroid right now, but we also have initiatives to build satellites and other equipment that can go to an asteroid. And then there are others who are thinking about refining the material in space to make it easier to transport. Because the problem is that, and this is also why the moon will play a crucial role most likely for us. The problem is you need to get off Earth and you need to go to the asteroid. You either need to bring all of your equipment there and then start mining there and then bring everything back, or another theoretical option we have is we go to the asteroid and we try to bring the whole asteroid or parts of the asteroid back
Wow.
and then do all of the refinement
Yes.
here. But in terms of us where we are now, it's all like very early stage. There are some players who like, I think one company from the Americans was recently in space actually and tried to test something and that kind of failed or didn't work as expected. So now they're like redoing everything and we're building our robot right now. And like even on the moon, we have like 3 or 4 robots now overall. I think India actually last year or even beginning of the year sent their first lander, if I
Yes.
remember
Yes. Yes.
correctly. So we see this kind of emergence of really the core infrastructure, the core technology getting built and getting tested in the next few years. And then making a prediction about when to do large scale asteroid mining is really hard because there's like a lot of things that have to go right and a lot of technology that has to be developed. But in theory, at least know that we can get to an asteroid and return things. The question is obviously also for the private
Yes.
sector. At which point is it cheap enough that what we have on an asteroid, and I mean, there is a lot on an asteroid, that what we can bring back will make economic sense.
Yes.
We're like trying to build the technologies and there's like a more interest on the general field also because everyone kind of wants to go to the moon. And that gives us like a relevant testing ground for a lot of the technologies we also want to use on asteroids.
Yes, yes. You know, the very interesting stat
That makes
and a
sense.
graph that I recently got to know, and that is about the gold in oceans. If we had to collect all the gold from oceans, it would collectively like count for $750 trillion or something like that. But it is just so difficult that if you want to extract all that gold, you're going to spend a lot of money in that and totally would become bankrupt just collecting all the gold. And that is like what is current condition of asteroid mining as well. We all know there is a lot of like kind of proper metals over there, but the extraction, the collection, the entire process is so much expensive that you cannot even afford such situations. And that is what just I read about something interesting. And also about the question is, when someone talks about asteroid mining, is like why in the first place we should do that. And also what would be the major difference in mining from earth and asteroid mining? What would be the major differences in that?
Yeah, so I think in the deep sea mining is a super interesting topic as
Yes.
well. I think in terms of what a major difference is, both kind of have challenges to get there. For us in space, it's more like you're targeting a moving object that kind of floats somewhere around in space. And like we have asteroids that kind of come close to Earth. The best ones are like 1.5 months away with current rocket technology to like get them, catch them. So that's very different from the deep sea, because in the deep sea, like you kind of know where you're going,
Yes.
right? And not the problem you have there is that you have intense pressure that you need to withstand. On the other hand, in space, it's more like heat, energy supply. Also, a core issue is fuel. All of those supplies. I mean, these are partly, and also radioactivity, because you don't have an atmosphere that shields
Yes.
you. So it's both are very extreme environments, I would say. No, obviously, very extreme environments, but it's very like from an engineering perspective, it's very different challenge in like different domains. I think we're still working on our planet, so we're potentially disrupting ecosystems, especially if we're mining on the deep sea. So we're destroying the seabed. We might be disrupting animals down there that have impacts on our ecosystem that we're not aware of. Compared to asteroids, where we are relatively sure that we actually might be removing threats to our Earth, because asteroids might actually crash on Earth or be a danger to Earth, but other than that, don't have any impact on the wider ecosystem of the universe, from what we can tell. I mean, maybe there is some impact, but compared to the deep sea beds, we definitely know at least it's not part of our planets, and we're not. That's also like hopefully an added benefit, that we're not producing carbon dioxide and like all of these bad side products of the mining cycle on Earth anymore and destroying our atmosphere. We're doing all of that in space, and then the only thing that we get back is all of the materials. So in that sense, I personally would say that asteroid mining is the cleaner alternative to deep sea mining. I mean, in a sense, they're also very similar, because you have a lot of legal questions actually in terms of who owns an asteroid, like who owns the deep sea bed. So in that sense, again, they're very similar. I mean, a super interesting question. Like, okay, we have like our national borders. And the funny thing is, in that sense, also asteroids, asteroids like give a possibility for countries that don't have these natural resources available to get
Yes.
them, which has implications because right now a lot of the rare earth minerals are locked actually in Russia,
Yes. Yes.
China, I think part of
Africa.
Africa. So there are even like geopolitical implications to
Mhm.
all of this.
But like also there is that question can be like posed this way, like not just asteroids but also on the moon, like who owns the land, like how is that divided in moon as well, like yeah, so
Yeah.
that would be a like kind of a problem.
Hmm.
And in future also, like once we get to a point where you can kind of like afford those things, the developed countries will just enter into a race to just get the things done on their own and get all the things under their control. Interesting. And coming back to the
Yeah,
yes,
I think
yes,
the different countries like going into
yes,
race, we kind of see that already. Like India is going to the
yes,
moon, China and America are always going, but there seem to be a lot of like smaller countries as well, kind of entering this race and like trying to get tech on there because they know this is like I mean, this is like
yes,
the new frontier. This is like the new Americas in a sense, without native
yes.
Indians, obviously.
Obviously.
We have so many resources on the moon as
Uh-huh.
well, so it might actually play a critical role in the
Yes,
future.
like moon is already becoming a race now. In some years we will see about that in asteroid mining as well, but moon is like already there's a race about winning the like southern part of recently the
Yeah.
India's lander landed on the southern part, something like that happened, and it was one of the like kind of thing happened with India. So other countries also trying to do the same. And also coming back to the asteroid mining, tell me about the exact like step by step process, like how do like companies like they will detect the asteroid, how, like what will be the timing of launching their satellites and how will that land. And the most interesting question would be like how like asteroid is already moving, so like how like they are going to make calculations according to that. So tell me something like step by step process of that.
Okay, yeah. So I think, at least from what I
Uh-huh.
know, what we're doing and what others are doing, there's like a lot of unanswered
Yes.
questions in that domain. So the obvious first step is to get to the
Mm-hmm.
asteroid. And for that, I mean, in a sense, getting there is the easy part at the moment because we know that the asteroid has a certain
Mm-hmm.
trajectory. We're on a certain speed, similar to a planet at the end of
Yes.
the day. And we know that I think there is one coming in 2026, for
Mm-hmm.
example, which I think almost no one targets because the technology is not ready, at least from what I know. And what you're basically doing is you're looking at the trajectory of the
Yes.
asteroid and you're calculating based on where Earth or the moon, depending from where you would launch. I mean, for us, I think in the next 5 years we won't have a launch base for big rockets on the moon, so it's probably from the Earth. And you're basically saying, okay, I know it's moving at this speed along this
Mm-hmm.
trajectory. If we launch from Earth in this direction and use maybe some gravitational force of another body as a flyby, and you use complicated
Yes.
math to and orbital transfer and like Hohmann
Mm-hmm.
transfers to like calculate, okay, how much speed do we
How
need? How
much?
much
Yes.
fuel do we need to like reach it at that specific point? And then you would launch in the time running economy. And the kind of the good thing is that all of that is reasonably well to calculate. So you don't have a lot of unforeseen things that can happen, at least in how the asteroid and the planets are moving. So you will be reasonably precise in how you get there. And then once you're reaching the asteroid, it's a matter of obviously either like rendezvousing with the asteroid, I think it's called, and you're adapting the speed of your rocket or your
Yes.
lander with the asteroid. And that means while both of you are moving super,
Mm-hmm.
super quickly in relation to each other, you're basically on a still stand. And at that point, you would start deploying your
Extraction
machinery.
machines. Yes.
Something we kind of learned in that regard from the past missions is that a big problem is actually, I mean, we kind of knew this, but a
Mm-hmm.
big problem is like actually getting on the asteroid itself because you're in a zero gravity environment. And what that means is that every force you send, like every force you apply will get reflected.
Yes.
So if I send my probe on the asteroid, it will not just land because you don't have gravity. So the force you apply will just basically straight bounce back, which makes it very, very hard to land on an asteroid. So what they did, for example, in the Hayabusa 2 mission is they didn't really land on the asteroid. They just had a gripper arm with like a vacuum cleaner. Basically, you can watch like there's a
Yes,
clip
yes.
on Wikipedia if you look for Hayabusa 2. It looks amazing. And basically, they touched down, they grabbed the sample, and then the lander was
And
removing
how much
itself
time did it
from the
take?
asteroid. I think the contact was not long, so I don't know. I don't know how long the exact journey
Uh-huh.
took to get there and all of that, but it's like it's literally a few seconds of contact. Like you go there, you grab it, and you go away. So you don't have a lot of
Yes.
time. This is, for example, something we try to solve with our robot, which is like a hexapod. It has 6 legs
Yes.
and has a gripper at the end of each leg that really would grip into the asteroid. But also then you need to make sure it gets there super, super
Mm-hmm.
slowly. That's actually a very, very hard challenge. I think that it still needs to be solved, like almost like a lot of parts of this process. And then another issue is, and that's something people don't usually know about asteroids, is that asteroids are not like solid
Yes,
stone.
yes.
They are actually like kind of more, I mean, not all of them, but they're kind of more compressed dirt. So the surface is not necessarily stable. It depends a bit from asteroid to asteroid. All of them have a bit of a different composition, but that also means that if you go to an asteroid the first time, you might actually have different conditions than you initially thought to have. And that's also something they figured out. Like if you watch the GIF of the Hayabusa 2 on Wikipedia, it's like it looks more like gravel and a lot of dust
Yes.
that's like getting also in the air and things. So
Mm-hmm.
it's not like it's not this clean rock that we all have in our heads when we think about an asteroid. So it's actually like a natural
Uh-huh.
environment with like dirt and dust and other things sticking to the surface,
Yes.
which complicates everything a bit more.
Yes. And like if you, let us say you extract metals from asteroid, now the process would start to come back to Earth. And what would be the steps in that?
So if we assume we kind of mine at the asteroid
Yes.
itself, and then you need like that's not, for example, that's what one of the American companies was doing. What they basically did is they took apart like for the demonstration. I need to check again if it worked or not.
Okay.
But basically, what they wanted to do is shoot a
Mm-hmm.
laser onto like a bit of rock, basically make it so hot that it becomes a
Gas.
gas,
Yeah.
and then they pull in the gas into the probe, and with some sort of analysis and some instruments, they would um, take out basically the gases that would,
Yes.
and then they would start cooling them
Mm-hmm.
down, making them liquid again, and then at a certain point solid, which would mean you had a very compact piece of material inside of your probe.
Yes.
And then that probe would just basically go back, like attached to a rocket, go back to Earth and just crash down somewhere on Earth. I mean, I think they also mentioned this somewhere else that the good thing about all of this is once you have your stuff inside your
Mm-hmm.
rocket or inside the capsule that's going to land on Earth, you don't have too much things to do as soon as you got the force and the fuel to get it back.
Yes.
And then because you don't have human payload,
Yes.
it's okay if it crashes down on Earth and like gets damaged or the thing breaks, or even if there's like a small crater. Like as long as the impact area is clear,
Uh-huh.
you're not losing anything because the material is like it's still there. Like okay, it might be scattered around a bit, but it's still there. So you have a bit of less of issues than, for example, if you're returning asteroids from the ISS, because these people actually need to
Yes.
survive,
Yes.
and you have different heat standards for like the protection of them. And then with this, with materials, everything would be a bit easier overall.